Good afternoon, everyone. My name is Michael Torres. I'm one of the professors at Northern Virginia Community College. I'm an adjunct there, as well as my full-time job is Senior Solutions Architect in Cloud, AI, and Cyber. Today, we're going to talk about a concept that I'm calling the A3 information age. And the general gist here in this particular presentation isn't so much the age that we're in as much as it is how we understand the variables within the age that we're in. So today I'm going to be introducing a couple of probably somewhat familiar concepts, connecting them a bit. Some basic concepts which are going to sound elementary but foundational for the purposes of what we're trying to understand for the end goal here. And then we're going to talk briefly about how we can begin to research and understand this new age and the impact this age will have on society and individuals alike. But before we continue, I want to see if anyone had any questions. All right, good deal. All right, so long story short, the Industrial Revolution, which is what we're in, has evolved 4 times over and has introduced different quote-unquote ages within every revolution. We're currently in the 4th revolution, but it started out we went from the agricultural to the industrial in the 18th century. Where we started introducing the steam engine and basic industrial building and things of that nature. We then went into electricity in the 19th and 20th century, and we got to our first information age, which is in the 21st century. I'm sorry, in the rest of the 20th century. And then where we're at now. So depending on the research that you read or the articles that you review, or funny enough, the news clippings that you peruse through, you'll find that they're calling this revolution by different names. They're calling it the Information Age Part 2. They're calling it the IoT, the Internet of Things revolution, and frankly, they're just calling it the AI revolution. However, in my opinion, one of the aspects about the age that we're currently in takes us long beyond technology. It takes us into our ability to integrate the cyber world and human aspects of our day-to-day life. And that's much different than just having a computer. We talk about scenarios like you see in the movies where robots are making decisions for you and catering to you and doing the tasks at work, at the job that you're supposed to be doing, very Jetsons-like. So this revolution, the one that we're currently in, is all about integrating our cultures, the technology culture and the human culture, and bringing it together and making it one society. And a key aspect to that, in my opinion, is based on 3 variables or constructs of technology that will help meld or integrate human society into technological aspects, right? So we have automation, autonomy, and that's a typo there, and augmentation. And what we'll do is we will explore all 3 to understand how it works and where it applies. Does anyone have any questions? All right. So the general gist is that when we talk about automated, when we talk about autonomous, and when we talk about augmented reality in today's speak, we typically talk about them very myopically, right? We basically say automated is RPA, right? Or some sort of automatic process that can execute tasks. Autonomous is specifically AI, when really that couldn't be further from the truth. I would say that autonomous isn't so much a particular technology like AI, or also known as artificial intelligence, but more so different types of autonomous processes and capabilities that can be integrated in any type of technology, with AI or without. And then the other aspect is augmented or augmentation. And the general idea here is we always think about augmented, especially today with all of the VR that we have, and Google Glass, although that's not a thing anymore, and some of these other aspects, is that we look at augmented reality where we overlay the cyber world over the real world. Being able to get live information from the web, from the internet, from data sources about what you're looking at. Very similar to facial recognition, or I always go back to Google Glass because that's always the more memorable of the augmented reality personal devices. But there's also another aspect of augmented technology, which is augmented processing. And the idea about augmented processing, which we'll dive into in the next slide, deals primarily with the extension or the enhancement of human capability, not necessarily creating a overlay of technology over the existing world. The general idea here is when we're dealing with automated technology, there's two types of automated. Although arguably, depending on what you read, you may find many categories and subcategories in each one of those. But I bucket it in two specific categories. There's assisted automated technology and unassisted automated technology. And the primary difference is that in assisted automated processing or automated technology, there is a human initiation, but there's an automated execution. So when back in the old days, when I was in the military back in the 90s, I used to use this now defunct weapon called the Dragon Gun. And the Dragon Gun was, for all intents and purposes, was a rocket launcher that was laser guided. Our nicknames were pop-up targets, the Dragon Gunners. And the reason why we were pop-up targets was because we could not move that laser beam off the target until it hit. So by the time we fired, we hoped it landed before the tank or anything else saw us and started returning fire, right? So in this particular case, using that example, the next type of scenario there is guided missiles or automatic guided missiles, whether it's heat related or geo related, or any of that nature. So where I was antiquated and I needed to actually control the delivery of the Dragon Gun's output. In the next level, which in my opinion is assisted automated rocket launchers per se, is where a human pushes the button, but the system itself guides, controls, and adjusts to ensure that it gets to its target. So that is the primary example of assisted technology, is human initiated, but system executed. Unassisted technology, unassisted automated technology is basically automation without human interaction. It's an example of today's technology that kind of drives unassisted automation is event-based architecture, right? If a system event occurs then it automatically kicks off this automation, this RPA as an example, and it automatically executes. So the human does not have to monitor and observe and determine when the execution of automation occurs. However, one of the key tenets of automation compared to the rest is that there is no decision making, right? There's a script, and when you automate and you're using automation in technology and in society, it could only execute the script that the human predefines. Autonomous processing is identified by three specific scenarios. You have scripted autonomous, supervised autonomous, and intelligent autonomy. Scripted autonomous is similar to its name, that it is designed to execute a very specific human-defined function, but has the autonomy to analyze and understand the variables that are involved in the execution of that function, compared to supervised, where this is a hybrid scenario where autonomous processing meets human observation and interpretation, where you have humans supervising the autonomy, and at any given moment, they can either provide input as a data point for consideration in the decision-making process by the system, or they can course correct by, based on variables. And then we have what we call intelligent autonomy, which is completely self-sustained, no human interaction autonomy. An example I like to use there is Skynet, right, from the Terminator. That is intelligent autonomy. Humans could not supervise and engage, could not control. It just had a goal, a plan of that it needed to execute, and then it began its process of discovery, and with very little understanding of what it was trying to achieve, or more importantly, the variables involved in what it was trying to achieve. It was able to observe, capture, interpret, understand, and then make decisions around those variables to help it get to its end goal. Another example I like to use, and that going back to the 80s, showing my age here, is war games, right? War games. We had the defense system where the primary actor, Richard Broderick, if I remember correctly, he thought he was playing a game called nuclear warfare. The system thought it was trying to figure out it was a training event to figure out the best possible way to win a nuclear war and then execute it, right? So that is an example of the scenario of intelligent autonomy. And then, of course, we have augmented processing or augmented technology, where augmented processing is specific to extending human capability to get the job done, right? So they may integrate augmented capabilities or features. So augmentation could be visual, like, again, I'll use a now defunct product like Google Glass, right, to simplify things, or these digital exoskeletons that you've probably read in the news that DARPA is working on for the military, to make them stronger, to literally do like in the movies where you put on this machine and this machine now becomes an extension of your being, and whatever you do, the machine does. The machine doesn't necessarily have the ability to make a decision. You control it, but the machine itself is integrated into your day-to-day interaction, existence, and activity. And then there's, of course, augmented reality, which is just the overlay of technology, of data, more specifically, with the real world. I'm going to pause there for a second and see if anyone has any questions. Let me see if there's a chat box around here. There's a whole lot of chats.
Hey, Michael, nothing yet.
Nothing yet? All right, very good. All right, good deal. Now, the next variable about these three constructs in the information age is the decision maker. One of the key aspects about defining a decision maker or about a decision maker is making sure that we define it equally, because different groups, different schools of thought will define the decision maker either as an individual, a role, or a set of activities. From my perspective, I don't look at the decision maker so much as a role as much as it is the set of authoritative capabilities that can be executed and by what, right? So some of these key activities are being an observer, which is default to everyone, and an interpreter, and a learner, which is universal to all actors in the process, right? But also have the ability to take its observations, its interpretations of observations, and what it learned from that interpretation to begin problem solving and understanding how to achieve the goal. And then the integrator. And the integrator is unique to my perspective in the sense that the decision maker's job is also to integrate different aspects of the scenario. So it can integrate realities, the cyber reality versus the human reality. It can integrate processes, it can integrate actions, but ultimately it has the ability to integrate capabilities through decision making. Now, the particular individuals or roles or the what per se that executes those tasks when dealing with automation, let me click on this again, there we go, is the human. When dealing with autonomous, even in scripted and supervised, for all intent and purposes, it's the machine. And then when dealing with augmentation, or augmented processing and augmented reality, it's both. The human engages the machine, and then the machine interprets and responds and does autonomous analysis and observation and interpretation to give human what they want, right? So it's a little bit of both. But ultimately, if augmented reality or augmented processing is done correctly, human still maintains full control, even if machine is making decisions. I would go as far as to say that within augmented reality, what we're really doing is machine is making recommendations to the human, and the human maintains control of the decision-making process. But
Hey,
the
Mike, I have a
research would.
question.
I'm sorry, Babur?
I'm sorry to stop you. There's a question. Do you want me to wait until the end, or should I just ask?
Oh, no, please go ahead.
So, which one of these A's, automated, autonomous, or augmented, is being used widely in the industry, in your opinion?
You're breaking in and out, Babur. I'm not, let me see if I can find the question here. I'm in the chat. I don't see it in the chat. Is there another place where I can go see the questions? Either way. Babur, can you try to restate the question? Did we lose you, Babur? Are you on mute? So the individual that asked the question, if you can go ahead and take yourself off mute and ask the question, that would be great. Going once, going twice. All right, well, if we get Babur back, or if the individual would like to pose the question on a later slide, I'll come back to it and answer it. Let me just make sure I didn't miss anything.
Hey, Michael, I'm sorry. Is this better?
Yeah, that's better.
Yeah, because my computer kicked me off. That's what happened. So
Okay.
I got a text message. So which of the A's, augmented, autonomous, or automated, is being used widely in the industry or the government?
Well, I'm glad you asked that question. All of them. Businesses, private organizations, and public organizations like state, local, tribal, and federal governments of all countries are currently using process automation, most commonly known as RPA, or robotic process automation. Um, and they're all using AI, or they're trying to leverage AI. Now, I would say that AI adoption and implementation is probably a little slower than automation, because automation, we're scripting and it's executing, versus autonomy, there's a lot of logic and learning that has to go, that's involved in building an autonomous system. Because in order for an autonomous system to work, it has to evolve very similar to a human, right? As a baby, you have no knowledge, but over time, you learn more knowledge that you can use to facilitate different tasks. So autonomous technology has to learn and evolve in order for it to be effective. So its adoption is slower because of that learning curve. And then augmented reality, there are a number of, I'm trying to remember the name of the federal program, but through the Geospatial Agency, they are trying to build these devices that they could hand auditors and law enforcement officers, federal law enforcement officers, with the ability to dynamically augment real-time information about over their perceived view or line of sight, both through weapon scopes and things of that nature, but also personal devices like augmented glasses and other personal devices. Did that answer the question?
Thank you.
No worries. And just to go back one slide, let me go ahead and back one slide. That's the reason why I say it's happening now. I'm not insinuating that it's the next. I'm insinuating that it's now. We're in it. We're in it to win it. And technology is yesterday's news. Computing is yesterday's news. It's like I often tell students that ask me, well, Mike, you know, should I go get a degree in, you know, computer repair? And my general response is, computer repair may be good now. The question is, will it be good in 5 years? When was the last time a refrigerator repairman came to your house, right? So I always tell people, look forward to your learning, or to determine what you learn. And what you learn in the forward, according to this context, is around the automated, autonomous, and augmented technologies. So, and I just explained this for all intents and purposes in regards to the difference between automation, autonomous, and augmentation. So to ensure that I don't run out of time, which looks like I am, I'm going to keep going. All right, so why does it matter? I'm going to fast forward here because there's only 15 minutes left. Long story short, right now, governments, different governments, different countries define their critical systems differently. The US has 16 critical systems as an example. However, none of them, or a few of them, identify data and information as a critical system. And I am proposing that in this particular case, data and information will become a critical system, primarily because when you augment or introduce automation, autonomy, and augmentation technologies, and you are integrating it with society, society in itself will be purely dependent on the data and information to execute its way of life. It's no longer something they just produce. It's now something that they depend on from the moment that they wake up to the moment that they sleep. And here are some examples of how data and information are being used today. To summarize here, it's used to assess risk. for different aspects, for insurance, for premiums, for legal implications, benefits, and it's used by governments to understand, identify, and interpret your being. It's used by the public to identify you. It's used by society to judge you, and more importantly, the more obvious, not more important, the more obvious is that the nefarious individuals, hackers, terrorists, things of that nature, try to use it to blackmail you or harm you one way or the other. And of course, the list goes on. But at the end of the day, data impacts our physical and economic security, public health, safety, and societal participation, which is why I'm saying it should and has to evolve as a critical infrastructure in order for A3 to fully reach its potential. And data is required to sustain, ultimately will result in being required to sustain an individual's healthy quality of life in the modern world. So I'm going to jam through these slides because we're running out of time. However, this particular serves to level set our definition and understanding of data, information, and knowledge. So for all intents and purposes, data comes in multiple different states. There are many types of data, many structures of data, and more importantly, many states of data. And right now, there's a competing schools of thought of when data is vulnerable and when it's not. And my proposition here is that because data is always observable, and I'm going to focus on the bottom right-hand quadrant, which is state of data, whether it's at rest, which is in its permanent data storage, whether it's in transit, which is moving from one stage to another, or whether it's in process, which is currently being analyzed, contextualized, and understood for the purposes of executing process or transaction. At the end of the day, it's all observable data. Whether it's temporary data or permanent data, it's all observable data. And the reason why that's important from an A3 perspective is because while humans are slow, quote unquote, slow to catch and see data, automatic, autonomous, and augmented technologies will be able to see it in real time as it's produced. And if it's temporary data and it goes away, it's already, it's okay because they already saw it. They already learned from it, and they already put the knowledge that they learned from it in place in all the decisions that they make. So, and I'm proposing that temporary data and static or inactive data or in transit data, whether it's encrypted or not, is all extremely critical to the A3 evolution or the age to reach its full potential, where today we're primarily focused about how we use data versus how we're able to observe data in all its states. Any questions? All right. So information, very simply, is contextualized data, right? It's our ability to bring meaning, relevance, time-bound, and structure to a piece of data or our data sets to make it relevant and understood to the parties involved. And then knowledge is nothing more than the ability to acquire permanent or retained data, for lack of a better term, either explicitly, for example, technical guides, or through tacit knowledge, which is subjective observation, your interpretation of the world. So one's based on facts and evidence, and the other one's based on your interpretation and observation of the world. But it's the information that you acquire and keep with you and you independently apply somewhere else. And the reason why this is important to A3 is because when we're dealing with autonomous and augmented technologies, the technology itself not only has the ability to observe, but also has the ability to learn, and as a result has the ability to acquire knowledge. And without really any notice, the technology can apply that knowledge as a outlier data point and impact or influence the decision-making process as it's consuming the data set. So it can take knowledge that it knows that's not part of the data set and overlay it on the data set and completely change the context and meaning and relevance of the data. So the data itself will be completely different once it's done. And then long story short, data is what we have and we use it to construct information. Information is what we understand and we use it to acquire knowledge. And then knowledge is what we retain from all the information, and it's what we, and it's the data that we have that we apply to existing data sets to construct new information. So ultimately, we augment the data with our knowledge to construct information. Any questions? All right. So the problem, time check, it is 4:08. Man, it is 4:08. It just ran by fast. So long story short, we are producing more data than we are able to manage. It's said that humans will likely increase approximately 48 terabytes of, exabytes of data every 2 years. It'll double every 2 years, right? And as a result of that, there's going to become a point where the data that's in the in existence and the data that you're producing, the sheer quantity of it will surpass our human capability to observe, manage, organize, and control that particular data. As a result of that, which is the A3 challenge in data production, is going unchecked, autonomy and augmented technologies, autonomous and augmented technologies may have trouble differentiating between fictional and non-fictional data, right? You know, like what's going on now, you know, fake facts, right? Fake news. So being able to, it may not have the ability to interpret between the two. And then of course, as I explained now, is it's not about if, it's about when. When we lose control of our data, when we lose the capacity to control and understand and observe and be aware of the data that's out there, that automated, autonomous, and augmented technologies are handling, analyzing, managing, controlling, and deriving quote unquote statistically sound decisions based on that data, is fundamentally a problem, because if you don't know what's out there, you don't know what the autonomous system is using in order to make its decision, right? So these are all of the challenges when dealing with autonomy, or the A3 evolution. The data brokers. So data brokers have been around since the beginning of the computing age. There's more data brokers out there collecting data about you and about everything that you do to understand your habits, your behavior, your decision-making process, and so on and so forth. That the landscape for this uncontrolled data is already there. Unless you can tell me every single data broker that has data about you and what specific data it has about you, you've already lost control. My previous my previous prediction of us not being able to control data is already a reality for you. And then of course the data profiling problem. And the data profiling problem is very simple. It's all this data that defines you, and indirect data that can be used to extend that definition that may not be related to you, ultimately is used to assess and understand you as an individual, your behavior, your decision-making processes, and ultimately profiling you as an individual, and even taking it to the next level of profiling you, your social groups, and the collective at large, and being able to understand behavioral paradigms and decision-making paradigms, both at an individual level, a group level, and a societal level. So digital profiling, next gen, is the challenge with A3. And the reality is that through A3, it's going to teach itself how to evolve. Initially, it'll be taught how to profile, but through its self-learning capabilities, it has the potential of evolving the digital profiling capabilities and methodologies to be much more efficient and effective, to instantaneously translating the world, its societies, its cultures, and its individuals without you even knowing, ultimately influencing you. I'm gonna skip this definition on data profiling, and I'm gonna get to understanding A3. And long story short, there are two perspectives to researching A3. There's researching the integrative components of A3, how it integrates with the world, and researching how A3 learns humanity, learns how to simulate human behavior, envy, bias, and things of that nature. I will say this, that because of COVID, it slowed down my research from when I initially proposed it at the beginning of the year. So I haven't quite drilled through the either one of these topics in much detail, but I am further along in the integration portion of this model than I am in the learned humanity, or the quote unquote behavioral portion of this model. And I'll give you a rundown on what I have on both. So the general idea on integration is that we can use a theory called general systems theory that specifically is was developed in the 1950s, specifically in 1956. That's used to define our system of systems. It was before technology even existed. It was a framework to define how evolution works and how our society, our systems evolve. And it's broken down into 9 different levels. So the first one, which in my opinion is probably the most important, is our framework. Having a good solid framework, taxonomy, standards, definitions, patterns, that is used to build our initial construct of A3 will lay the foundation for how A3 evolves and its capability of humanizing intention, right? Then we have process, which deals with the execution of predefined tasks. We have cybernetics, which is the ability to integrate and understand the basics of a systems with bound constraints. So where Clockworks is executing a predefined process, now systems have the ability, have some latitude, but with constraints on either end. And the one that I would use is a thermostat as an example, right? And then of course we have open systems. And open systems is the general idea is the regeneration or the resiliency, the recovery, the recoverability of a system. Back in the 50s, they used the human cell as an example, being able to regenerate or reproduce itself. And ultimately, these are considered self-healing systems. So how does A3 apply to this? Well, framework defines it. It gives it its foundational baseline, ultimately defining its quote unquote its A3 identity. It's for automation, it's able to execute processes. For augmentation, it's able to function within cybernetics. And then for autonomy, it is able to assess and recover without human intervention. Then we have genetic societal, which is the idea of formation. This is applicable to how like constructs start forming, norming, forming, storming, and norming, right? Being able to create cellular structures like terrorist cells or like school groups and working on a common task or process or execution. And the idea here is that we will be able to leverage the theory and the research around genetic societal systems models to understand how autonomous and augmented and automated technologies and systems will be able to ultimately integrate with each other to execute larger, more complex activities. So self-integrating formation of augmented and autonomous technologies. And then through autonomy or autonomous technologies is the development of perception and awareness and response, is the idea to observe, interpret, and be aware of your surroundings at all times and translate those surroundings in real time so that way you can make a decision and respond. In the image model, which is typically was associated in Boulder's framework as the animal, is that they're not able to interpret the world per se as much as it is they're able to interpret their surroundings based on environmental variables. It's hot, it's cold. And then lastly, it's where I believe the challenge lies that leads into my second perspective of analysis with A3, which is the human societal organization and transcendental. So human is about being able to develop an understanding of the world, your surroundings and other beings, and being able to develop self-consciousness and self-reflective to create synthesis of the world and your own being. And my argument, or my argument here is just through the natural stage of evolution, which has been in existence since the beginning of man, or the world in general, AI or autonomous technology will naturally evolve and could, like in the movies, is where science fiction starts meeting reality and could ultimately develop consciousness and self-reflection. That's theoretical, of course, and that would need to be proven through research. And then, of course, societal integrations. Can A3 create its own digital societies that is separate and apart from human societies? Can augmented reality facilitate both these digital societies and these human societies in the same existence? And transcendental is the ability to capture, understand, and deal with any unknown variable that can ever be presented in any scenario. Any questions on this approach to research of A3? All right.
Hey, Michael, excellent presentation. We're about someone asked, are you going to share your slides?
Yeah, I'll definitely share my slides. I'll send them to the meeting organizers. But lastly, the learning humanity is a behavioral model that will allow us to assess the technology's ability to emulate human behavior and human intentionality. I will say that is the long pole in the tent. That will likely take years of research and a lot of manpower to kind of wrap our heads around, but this is the very last construct in the last slide. Sorry that we ran out of time, but it was a very complex topic to unpack. Hopefully I did that in an acceptable way.
This was an interesting, very interesting topic, absolutely complex. Appreciate your time, Michael. Thanks everyone for joining us.